Okay, today's lesson is 88. It's review of proportional and non-proportional relationships. What's our objective, class? Get ready?
Review of proportional and non-proportional relationships.
Very good. Today you're going to identify tables, graphs, equations, and story problems and decide if they're proportional or non-proportional. We're also going to look at some sample rise questions to determine if something is linear or not linear. 3 key ideas to recognize whether or not it's proportional is the first one. It has 2 variables. How many variables? Get ready?
2.
2, because remember the form y equals kx? Y and x are your variables. K is a constant. It'll be like a slope, like 2/3, okay, or pi. Number 2, all pairs form equal ratios. That means your constant of proportionality, you have a K, okay? We're going to say you have a constant of proportionality. What do you have? Get ready?
Constant of proportionality.
Constant of proportionality. Just remember real quick, if you had an input and output like this, okay, you would say, oh yeah, I could find my output divided by input, output divided by input, and you say that's 4/2, that's 6/3, that's 2, that's 2. Oh yeah, my constant is K. So a proportionate relationship has a constant. Number 3, it's linear and through the origin. What's number 3? Get ready?
Linear and through the origin.
Linear and through the origin. Now, this is linear, but it's not through the origin. So you have to have something that either starts at the origin or goes through the origin and go at any angle, but it has to go through the origin. So we'll do more on that later. Okay, the root word of linear is line. So if you forget what the word linear means, it's just a line, it's straight. We talked about y equals kx. You're going to see on the rise test words like this. As one variable increases, the other variable increases at a constant rate. Constant rate, that's your slope, right? That's the K, that's the slope. So looking at a graph, it says like as I move up, I'm going to go the same rise, run, rise, run, rise, run. I'm going to go at the same rate. That's what you're going to look for. As one increases, the other one increases at the same rate. So let's quiz you guys. How well can you identify some relationships? Are they proportional? Yes or no? Look at this one. I'm going to call on a few students. I'm going to call on, how about Samantha? What do you think? No, because it doesn't go through the origin. She's absolutely right. Okay, so no. How about this one? Does this one go through, or sorry, is this one proportional? Lexi?
Yes.
She says yes, debate it. Why? Give me all the evidences.
Because it goes to the origin and it's straight.
Goes to the origin, it's a straight line. As one increases, I increase at a constant rate. Gage, thank you for raising your hand.
12 at the end of both.
12 what?
At the end of both. That one was 10 at the end.
You know, the numbers won't change whether it's proportional or not. This could be a 2 and that could be a 12. As long as you have a constant staircase, it's stepping up and going up at the same rate. Okay. And 2 variables, pounds and dollars. That's 2 variables, right? Pounds and dollars are 2 variables. What about this one? Is this a proportion? Emma?
No, what do you think?
She says no. Why?
Because it's not a straight line.
It's not a straight line. It's that easy. It goes through the origin. I've got 2 variables, but I'm not going to step up. If I step here and here, then I have to step way over here. It's not going to be a constant rate. Okay. All right. So you guys passed the test. Now we're going to look at another scenario. Suppose they don't give you a graph, but they give you some tables. So here we're talking about a small square, a side length of 2, its perimeter is 8. A little bigger square, its side length is 3, its perimeter is 12, 4 is 16, 5 is 20. Is this proportionate? We don't have a graph. How could I look at this and see if it's proportionate? Jasmine thinks what?
Wait, am I answering or am I
Yeah,
explaining how to
both.
answer it? Okay, so, wait, which one do we want me to say first?
Well, is it proportionate?
Yes.
Yes, how do you know?
Because each of them is times by 4, and if x is 0, when you times it by 4, then it's still 0. So it'll be through the origin, and it's going at a constant rate.
Okay, that's a weird way to say the origin, right? I had some students go, I know you said goes to the origin, but I don't know what point that is. Well, it's the point 0, 0. Yes, we know that. All right? So, and it has a constant, a k, a constant, right? So every time you multiply by 4, how do you know? Take your output divided by your input. Is it the same every time? Then yes, it's proportionate. Is the area proportionate? Side length 2, area is 4. Is the area proportionate? Give me a nod, yes or no. I'm going to see where your vote is. I'm seeing mostly no's. I'm seeing Emma's thinking yes. But hold on a second. I want to hear Holden's. Holden says no. Why do you think it's not proportionate?
Because if you divide, or the formula, it's 2, and then that one's 3.
Ah, you can stop right there. You just show two that are different. It can't be proportionate. Okay. Okay, very good. I like it. All right, so that's one way to check in a table. Okay, so now it's your turn. Here's a table. Will you do the same thing that Holden just checked? And then write on your paper a yes or no. I'm walking around. Is that proportionate? This happens to be the height and base of a triangle. Is that a proportionate relationship? Still thinking? Kaylee, what did you say? Is this proportionate? Yes or no?
I
You said yes. Give me your proof.
don't have to. Well, so I just looked at the line. It just looks, it's straight and it's, going
Well,
to the origin.
This definitely is proportionate, but the question is if I took this base and stretched it out to a 3, and the height then became 4.5, so what's it, 1, 2, 3, 4.5, is that also proportionate? In other words, is this whole relationship proportionate? Hannah, what did you test?
Well, the height divided by 1.5 equals
The height divided by the base equals 1.5. Is that true every time? Output divided by input. Output divided by input. Output divided by input. Every time it's 1.5. Is that our constant of proportionality? Yes. So then we can say yes. Would a 0, if it had 0 base, would it have 0 height? Yes. So it goes through the origin. Okay. All right. You guys are passing so far. Okay. What if your question, what if it said no table, no graph, but it gave you just equations? Can you look at an equation and determine if it's a proportionate relationship? Let's look. 2 variables. Is pi a constant? Yes, pi is 3.14, et cetera, et cetera. So this won't change, but I have 2 variables. Would it go through the origin? If the distance was 0, would my circumference be 0? Yes. Is this a constant rate? Yes. So this one is a proportionate relationship. Jasmine?
Can I answer the next 2?
Yeah.
Okay, so that the next one's not proportionate because things that are squared never are proportionate.
Okay, that's a really fast check. Anything with an exponent is going to have some type of curve to it, so no. And then I want to hear Lexi's on this one.
Anytime you add or subtract with relationship, it's not equal because it curves. It can curve.
The exponent will make a curve. This one does something a little bit different. Remember our mx plus b? What is the b?
But it goes to the y-axis.
Where it goes to the y-axis. So this one can't go through the origin because it's got a +1. I had 4th period vote. This is mx plus b, y equals mx plus b. That's an intercept. So if you see any plus or minus, it's shifted off of the origin. It can't go through the origin. So you know instantly it's not proportionate. Let's look at some story problems. Let's look at A. If 2 workers take 5 hours to complete the job, how long will it take 4 workers? Okay, so let's say Avery and Gage are having to wipe the tables down. It takes them 5 hours. But then Annika and Jasmine go and help out. Is it going to take them 10 hours? Because there's twice as many helpers.
No, 2.5 hours.
It's going to be like half the time, right?
Yeah.
So basically you're saying, wait, so increases, the time, here's 5 hours, the time should decrease. So that means if this takes there, then this should take like there. So it should get smaller. Could that be proportionate? If there's no way that can go through the origin. It's going this way. It's going like this. Okay, so that's like an inverse. This gets bigger, this gets smaller. Part B. The shipping charge is $2 per item plus $3 flat fee. Ding, ding, ding. As soon as I hear these words, I'm like, oh, I know the answer. It's $13 to ship 5 items. What's the charge for 10 items? Does it even matter? Because before I've shipped any items, I have a flat fee of $3.
No.
Is that through the origin?
No.
No. So it's going to look something like that. So not proportional. So no. How about part C? Jasmine.
So anytime that it says flat fee, that means it's not gonna, okay.
Absolutely. Like you're in a taxi cab, the flag drop rate is $2. Okay. Oh. Okay. I left that one for you. Okay. Each student reads the same number of books. 30. Oh, hold on. I just saw a ding, ding, ding word. You see that? It's like, oh, I think I know where this question's going.
Yes.
30 students read a combined total of 150 books, and they all read the same number. So 60 students, how many books would they read? Well, I go, oh, well, these would fit 5, and so it'd be the same. Is that proportionate?
Yes.
Yes. Give me a nod if you agree. Yes, I can see it. I know we're covering this fast as a long lesson. Emma.
It's 300, right?
Yeah, very good. Okay, good. All right, here are the last 2 RISE questions that you probably saw things like this last week. I know the first one I saw last year, something like it last year. Which of these, now we're going to talk linear. Okay, let me back up. All proportionate relationships are linear, okay, because it's a straight line. But are all linear relationships proportional? No. This is linear, but not proportional, okay? So the question is that a graph of a line? Is that a line? Is this a line? Is this a line? We're gonna vote. I want you to look at those. You have 10 seconds to decide, and we're gonna vote. I just wanna see what you guys think. Okay, if you think A is a line, raise your hand. If you think B is a line, raise your hand. If you think C is a line, raise your hand. If you think D is a line, raise your hand. Okay, D is correct. I can see though why you're thinking, a few all day have thought this one's a line, in fact a lot in 4th grade. Because you're like, hey, it's got the YX, but they weren't so sure about this. Anytime you have exponents, there's gonna be a curve. This one happens to be a circle with radius of 2. This one happens to be a parabola going through the y-axis at 2. A parabola. This one happens to be an odd numbered exponential, right? Where it's going to go up and then down right here. So we haven't covered it. You'll do these in high school. Super fun.
My sister taught
This is
me.
the only one that could be a line. There's no exponents. There's no exponent, no exponent. But wait a minute, Mrs. Boone, you taught me that lines look like this. That doesn't, wait a minute, could I move this over here? And could I divide by that 3? Could I make it look like this?
Yes.
I totally can. We have a lesson on this coming up in a little bit. So D is the only correct choice. That's the line. Okay, last RISE question. There was one like this on your benchmark last week. This is for 8th graders. 7th graders, you probably didn't see this question. They gave you tables and they said, just based on the table, which graph could be a line? So I'm going to show you a strategy you can figure this out. They'll trick you because they give you your X input and look at what's going on here. It's skipping numbers. See that? Okay, stay with me. I need everybody with me. Everyone's still, blood's moving, brain's still thinking, okay? I'm jumping up by 2 units, and usually tables don't do that. But then all of a sudden here it jumps up 1 unit, so I'm going to kind of ignore that for a second. So this is jumping up consistently, like think about my run to, run to, run to. What about my rise? My rise is going up 1, my rise is going up 1. Uh-oh, my rise just went up 4. So if I were graphing this, I'd go rise 1, run 2, rise 1, run 2, rise 4, run 2. Is that going to be linear? See where I got the 4s and 2s from, the 1s? I'm just doing rise, run on my change between. So this one could not be linear. It's because there's this big old jump right there. How about this one? I'm stepping up 1, stepping up 1, stepping up 3. So I'm probably going to ignore this one. But then this one steps up 1. How am I stepping here? Subtract 3, subtract 1. I stop right there. Is my rise and run consistent? No. Okay. I don't care about output divided by input. That's just to check if it's proportional. But to check to see if I'm stepping up at a constant rate, that's how I can check. So because those two right there, I'm looking for, I need some numbers with the same. All right, stepping up 2, stepping up 2, stepping up 1. I'm probably going to throw that one out. Stepping up 2. So I'm going to just not look at this one. All right, so stepping up 2, stepping up 2. I don't care what happens there, but here I'm stepping up 2. Do I have a consistent up, over 2, up 2, over 2, up 2, over 2? Yeah, I'm looking for that constant rate of change, that constant rise over run. So this one is linear on a cut.
Why do you just get rid of the one that doesn't match?
Well, because I want to make sure that for every 2 that I step up, I'm stepping up 2. For every 2, I'm stepping up 2. And here, if I'm stepping up 1, I may not. I shouldn't step up 2 here. So I just want to make sure I'm looking at just ones that are consistent. So probably I step up 1, and I do. Okay. Did I explain that right? That makes sense. Okay. Okay, good. Any questions? You guys are going to be fine on your practice set. Don't even worry. We're on 589. Thank you, Emma. Okay,